This is section 5.4 in the notes. This is all about solving logarithmic equations. Okay, so the last section was solving exponential equations. Notice in this section, 1, 2, 3, and 4 down below all have logarithms. So the first step is going to be to isolate the logarithms and combine. Isolate the logs, meaning get them all on the same side, and combine. Combine them into a single logarithm. Now, you're probably going to use the log properties to do that. If you look at number 1, there's only one logarithm, this natural log. So when we isolate it, that means you're going to move the 10 to the other side. However, on number 2, you can see that there are two logarithms. Now, they are both on the same side, so they are isolated, but you're going to need to combine those into a single logarithm, okay? Once you isolate the logs and combine them into a single logarithm, the next step is going to be to change to exponential form. Okay, why don't we, instead of filling out the rest of the steps here, why don't we go through both of those steps? So on number 1, isolate the logs. I'm going to get this natural log by itself. So if I subtract 10 from the other side, so I'm moving 10 to the other side, then I'm going to have negative natural log of x plus 1 equals, and if I'm subtracting 10, I'm going to have negative 7. So really, the logarithm is not by itself yet because I have that negative. But do you see that if I were to multiply both sides by a negative, all that's going to do is make both of these positive. Okay, so the logarithm's by itself. Now that the logarithm's by itself, I'm going to do the second step and change it to exponential form. Well, remember, if it's an ln, there's this little hidden base of e right there that you don't see. So if I'm going to change this to exponential, I'm going to say e to the 7th. Remember, the log always equals the exponent, equals x plus 1. Okay, so I've changed it to exponential. The last step is to solve for x. Okay, solve for x. Now, in this case, if I want to solve for x, that just means get x by itself. Well, the only thing I need to do to get x by itself is going to be to subtract 1. So I'm going to have x equals, on this side I have e to the 7th, and then I'm subtracting 1. And it's perfectly fine to leave your answer like that. You don't need to put that in your calculator and get a decimal. E to the 7th is just some number. Remember, e is like approximately 2.7, so whatever 2.7 to the 7th is, and then subtract 1, that's what x equals, okay? So the hardest thing about these is going to be the fact that your answer is going to be ugly, but it's okay. As long as you get x by itself, you're done. Okay, so look at number 2. I have two logarithms. They're already isolated because they're already on the same side. So what I need to do is combine them. So because this is a plus, right, I can use my log property that says when you combine them, you multiply. So I'm going to have log base 2. All right, if I multiply the x times the x minus 7, I'm going to have x squared minus 7x equals 3. So I've combined the two logarithms into one using one of the log properties. The next step, so I'm on like step 2 or step B above, is to change it to exponential form. So the base is 2. Remember, the log always equals the exponent, so 2 to the 3rd equals, what's left is x squared minus 7x. So let's see, 2 to the 3rd is just 8. So really I have 8 equals x squared minus 7x. Now, in order to solve for x, notice I have multiple x terms, but the real hint here is the fact that I have an x squared. And so remember, if you have an x squared, the easiest way to solve is to see if you can set it equal to 0 and factor. So I'm going to subtract 8. So I'm going to have 0 equals x squared minus 7x minus 8. And now let's see, can I factor that? Yeah, it's 3 terms. So let's see if we can do a trial and error. So I'm going to have x and x. And what if I do a minus 8 and a plus 1? I think that's going to work, right? That'll give me the negative 7 in the middle. Okay, so finish. I'm not done. So solve. So x either equals positive 8 or x equals negative 1. Okay, the reason there was an extra blank up here at the top is because for D, you need to kind of do a check. Basically, you can't take the log of a negative number. So if you end up with x to be a negative number, you need to eliminate it. So I'm just going to say here, eliminate negative answers. So that means x cannot equal negative 1, but x only equals 8. Okay, let's try the next one. So if you look at number 3, all right, there's actually 3 logarithms. So let's start with the left side. Let's combine these two, right? It's addition. So I'll combine them using multiplication. So I'm going to have natural log, which is base e. And if I multiply x times that parenthesis, I'm going to have 24x squared plus 11x. And on the other side, I have natural log of 18. Now here's an example of one that can be turned into a shortcut. If you notice that you have a single logarithm on one side and a single logarithm on the other side, not 2 on one side and 1 on the other, but if you have one logarithm on each side, then it's not really like they're canceling, but essentially what you can do is kind of eliminate the log. If you have a log equals a log, you can automatically kind of eliminate that part and then just say that what's inside the log, 24x squared plus 11x, has to equal what's inside the log on the other. Okay? So now, in order to solve, if there's an x squared, wouldn't you just try to set equal to 0 and factor? So 24x squared plus 11x minus 18 equals 0. Let's see, can I factor that? I don't know. I would start about thinking of 6 and 4. Now, there's no guarantee that's going to work. Let's see, for 18, could I use 6 and 3? No. 9 and 2? No. 18 and 1? No. So that means this can't be 6 and 4. So how about 8 and 3? Okay. So for the 18, could I use 6 and 3? No. I think I could use 9 and 2 if I put the 9 and the 2. Let's see, I need a plus and a minus. What if I do a plus here, minus here? So negative 16, positive 27. I think that's going to work. That'll give me the 11 in the middle. So x either equals negative 9/8 or x equals positive 2/3. And remember our check, you can't have a negative answer. So x is just 2/3. Okay, look at number 4. Now this is not the same as number 3 in that, yes, I have a log on each side, but the one on the right side also has this plus 3. So it's not just a single log equal a single log. So I can't just eliminate the logs on this one like I did on number 3. What I'm going to need to do is go back to the beginning where it says, get your logarithms on the same side. So I'm going to take this logarithm and I'm going to subtract it so that it's on the same side as the left side. So I'm going to leave the natural log of x plus 2 over there on the left. I'm going to subtract the log of 2x plus 5. And I'm going to leave that 3 on the right side. So I've isolated the logs. I've gotten them to the same side. And so now, because it's subtraction, when I combine them, it's going to become a fraction. So I've got natural log of x plus 2 over 2x plus 5. So it's the log of that entire thing equals 3. Okay, so I've just done this first step. I've isolated and combined. Now I need to go on to this step where I change to exponential. All right, so my base is e to the third equals x plus 2 over 2x plus 5. Okay, here's where the solving is going to get a little tricky. So e to the third is just some number. I mean, for all I know, it's like 25. It's going to be difficult to solve for x because I have x in both the numerator and denominator. Okay, so when that happens, here's what we need to do. Let's start by getting rid of the 2x plus 5 from the denominator. You might think of it as multiplying by 2x plus 5. If it's easier, you might think of this as being over 1 and then doing cross multiplying. So basically, I'm going to have e to the third times 2x plus 5 equals 1 times x plus 2, right? I'm thinking of it as cross multiplying, okay? Not crossing out, but cross multiplying. Now, if I'm trying to solve for x, I need to get the x's on the same side. But right now, I have some x's in the parentheses. So the only way to get rid of that parenthesis is to distribute that e to the third. So when I multiply e to the third times 2x, I'm just going to have 2e to the third x. And when I multiply e to the third times 5, I'm just going to have 5e to the third. And on the other side, I have x plus 2. Now, I know this is strange looking, but remember, 2e to the third is just a number. For all I know, it equals 10. It's just a number. So in order to solve, whenever you have multiple x terms, here's an x term and here's an x term, you want to get them on the same side. So I'm going to move this x over to this side to be with the 2e cubed x. So I'll be subtracting that x. And at the same time, I'm going to move this over to the right side because it's not an x term. So on the right side, I have the positive 2 that was already there, and I'm subtracting the 5e cubed. Again, I know this is strange looking and it's ugly, but we're really following the same principles of solving that we always have. It was just never looking this ugly. Okay, we did something similar to this the other day. If I want to solve for x, right, I've got these two x terms on the left. How am I going to separate that x from the rest of it? Well, on the left side, I'm going to take out a common factor of x. It's going to leave me with 2e to the third minus 1. On the right side, I have 2 minus 5e to the third. So in order to solve for x, just divide by that entire parenthesis. So x is going to equal 2 minus 5e to the third all over 2e to the third minus 1. Again, I know it's an ugly answer, but I've got the x by itself and everything else is on the other side. Okay, so those are the different kinds of things that can happen in solving log equations. All right, so you've got some homework to practice on, I guess, page 186 and 7. 186 and 187.